Welcome to Maths with Mrs. V. In this lesson, we're going to be continuing with functions and inverses, but particularly focusing on the parabola and restricting the domain of the parabola so that we can create a function when we find the inverse graph. So let's have a look at this graph. We have f of x is equal to x squared. So in order to get the inverse, we can go and work out y is equal to x squared, and then we can switch the values around. And we can isolate y to get our graph. So we know that that's going to be plus or minus the square root of x. And those two graphs have been plotted already. But we know that the inverse graph is not a function because it does not pass the vertical line test. So what we can do is we can actually restrict the domain of the original graph. So let's only focus on positive x values. And so that's going to get rid of the left arm of the original graph. And then when we find the inverse, we are actually going to only get positive values, and the inverse graph will then look like that. And so what we end up with is a graph that has been inverted, but its range now is only positive values. So the domain of the original graph becomes the range of the inverted graph. And we can also look at the range of the original graph becomes the domain of the inverted graph. And so those are the properties that we can look at when we are restricting the domain, and we can see how that will result in a function for the inverse graph because we now have the vertical line passing only at one point. And now we can write the new inverted graph in function notation because we have restricted the domain of the original graph, which means that we're only interested in the positive y values of the inverse graph. We can now go through the same process of finding the inverse graph and restrict the domain to only negative values. So when we work out what the inverse graph will be, we know that we're only going to use the negative y values because our domain in the original graph were only negative x values. So the graphs, in fact, will eliminate the positive x values from the original graph, which gets rid of all the positive y values from the inverse graph. And now we can write that in function notation because it is in fact a function as long as we show that we have restricted the range values. We can do the same thing now for the negative parabola. So what we'll end up with is switching around the x and y values, and then solving for y will give me y is equal to the plus or minus square root of negative x. And then we can restrict the domain of the original function to be only positive values. That will eliminate the left-hand arm of the original function. And so then what we're left with in the final function will be only positive y values. And we can say that y is greater than or equal to 0. And so the final graph will look like that. Since we have negative x underneath the square root sign, x has to be less than or equal to 0 in order to get a real number. And for the final scenario, I'm going to restrict my domain to be only negative x values. So I'm going to go and get rid of all the positive x values on my original function. And then my final function, the inverse function, will be the negative square root of negative x because I'm going to have only negative y values. And so I can eliminate on my inverse graph all the positive y values, and that is what my inverse function will look like for this graph. Again, we have a negative under the square root sign, and so x must be less than or equal to 0 to get a real number. Here we have a summary of the 4 different scenarios so that when we find the inverse of a parabola, we can restrict the domain so that the inverse is also a function. Please like and subscribe if you found these videos useful.